Good afternoon, everyone. I am Pulkit Gupta, host for the webinar 4.0. I warmly welcome our esteemed speakers of the day, trustees of VES, faculty members, architects, and students. Before we begin with the event, as a part of VES tradition, I would request everyone to join me in chanting Om 3 times. Om. 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 VES Converse webinar series aimed to bridge the gap between the academia and the profession. The journey began in the month of June when our first webinar series based on World Environment Day, positioning biodiversity, where speakers address the need of exclusive approach in design from the lens of ecology and biodiversity. At the same, we have been done a second webinar in the month of July, which is on exploring design thinking as a process, looking as an aspect of pre-design. The third webinar series was based on basically the concept to design factor of it. And all the webinars is very well linked with the design process in the built and construction environment. In consideration from the theme of this webinar 4.0 is alternative construction technologies. This webinar will approach on the paradigms of design and build practice. It will introduce to the process of manipulation of form to the method of construction of space. This webinar is spread over 3 consecutive days. Starting today, we have our 2 very distinguished guest speakers with us presenting today on this platform. With this, I would like to invite the moderator of the session today, Assistant Professor Abhijit Sehstrabudhe, to take over and continue with the proceedings in introducing the speakers. Thank you.
Thank you for that welcome note, Pulkit sir. I welcome everyone to this webinar again, all the guests and participants in this meet. Additionally, we have about 80 to 100 VESCO students who are attending this webinar through the live link on YouTube. A warm welcome to all of them too. Side note that a certificate of participation will be awarded to the participants who attend all 3 days of the webinar and fill up the Google form at the end of each day. Link of the form will be posted towards the end of each day. Let us now begin with introduction of our first guest, architect and Professor Girish Doshi is an architect based in Pune. He is involved in designing residences and institutions. After graduating from BKPS School of Architecture, Pune University in 1980, he joined Master Architect Balkrishna Doshi's studio, Sankalpa, in Ahmedabad. After 7 years of apprenticeship with him, he started his own studio, Navkar, at Pune in 1987. When it comes to work philosophy, Navkar strongly believes that architecture is not a simple manipulation of form, but is about construction of space and place. Light plays an important and decisive role in their design. Authentic material, pure geometry, and nature are the essentials that make architecture. And rightly so, he has titled his talk for the day as Construction of Space and Place. With this, I request Pulkit sir to stop presenting the poster, and I welcome architect Girish Doshi sir to start and begin with his presentation.
Hello everyone. Thank you for inviting me. I'm especially VESCON and team VESCOA for inviting me and giving this opportunity to talk to students. Now I will start my presentation called Construction of Space and Place. And the first slide is about late Vishnu Devakar Joshi, my mentor and my guru, who was part of Stein's office in Delhi after returning from England for almost 40 years. And he's the one behind all the great buildings of Stein. Without V.D. Joshi, it was not possible to go to such a high level. So very methodical, very simple, frugal person as far as his living is concerned, but very high thinker in every aspect. So he actually taught me. I actually was very lucky to meet him when I was working with Doshi in 1980, and he invited me to paint a small village near Mumbai to actually take a Khadi Gramodyog workshop for mason, plumber, electrician, and we taught them ferrous cement. And I was very lucky. Of course, I was very novice, but his energy rubbed me. And after that, certain things changed in me. Like till that point of time, I was talking about different things. But after meeting Joshi sir, it was some other direction started. And I'm very thankful to God Almighty that he came in my life. So he taught me these three things specially. One is RBC, reinforced block construction, and second is ferrogamy, art of ferrous cement, and third is PRB, poured rubble masonry, technology for rural area. So I will start with this slide first. This is where I stayed with him for 2 months. This is his house in Payne. You can see black Jeep parked there. He used to take that to airport. From there, he will go to Delhi. He will work there for 5 days, and he will come back on Saturday, Sunday. And his wife, Malini Tai, absolutely great woman. She will look after the workshop. The workshop on left-hand side, which slide you see his house from inside, and on right-hand side, this is his workshop where he started practicing ferrous cement. And he, in fact, stayed there for almost like 14 years. And he was doing dual thing, going to Stein's office as well as handling this team of Adivasis. And I'm very fortunate. Still, those Adivasi, they work for my son, Arjun. These are the three main blocks, actually. First is a hollow concrete block, which is 200 wide and 400 long. Second is a cavity block, which is 150 wide and 400 long. And third is a cavity block. So specialty of this block is that if you see, the dimensions are not 400, it is 1 centimeter less. It is like 390 mm. And in height also, it is not 200, it is 190 mm. So that 1 centimeter we have kept for horizontal cement layering and also for vertical. So when this two block touches, there is space in between, and where we can pour concrete, cement concrete, so the leakages will not happen. So over the period of time, this got improved more and more, you know. So we started with this kind of footing details initially. You can see that corner reinforcement, and later on what happened was only single bar was required. So now I'm working with, after his death, I'm working with Himanshu Tupwe. He's another great engineer, and he reduced the steel in the corner. So now it is just 112 mm bar. You can see PCC level at bottom, and then you can see double block, that is 400 thick wall till 3 layers, you know, according to the land requirement. And after that, you have only reinforcement on the edge where the walls will come, and then simple load bearing construction will start with cavity block in the corner. This is a footing detail. So he had a very simple methodology for everything. Like suppose it is a plus column where four side load will come. The size will be 1200 by 1200. Suppose it is T, then it will be 800 by 800. 1000 by 1000. And if it is just L, then it will be 800 by 800, and it is 200 thick. So his idea was that that you just need this small machine So we had this 2-block making machine, and it is hand driven, and punching happens with electricity. And then with this, you need small mixture, cement mixture, half-baked cement mixture. So you get proper, as per his requirement, the masala for the concrete block. And then you start making. By that time, plan will go to corporation and will get approval generally in 2 months' time. By that time, we will produce a lot of blocks, and we will keep it around the plot, So where excavation is not going to happen, the right margins will be with these concrete blocks. So, and then in some, luckily in Pune, some areas where our starter is very strong, almost it is stone. So there we just start with this reinforcement at lower level. And now you can see egg laying machine, which we have. So this produces 4 blocks at a time. So here manpower is required very less in the terms of, they don't have to do anything. They have to just push the button, and that machine will go on its own, and it will egg lay the blocks, 4 blocks at a time. And then construction starts. This is the old method of doing things, where we had this 4 bars. Then for filler slab, we used to stick this 150 high blocks to each other. So it becomes 400 by 400, and it looks like this, So lower part we will have always 10, 8, 10, and 12 mm bars as per requirement, and upper reinforcement will be always 8 mm. And then we have this 6 mm tile, so the distance between the 2 bar will remain same. So above we have a 50 mm layering of concrete, and ribs are actually 50 mm wide. So now you can see the slab is laid, and all the beam becomes part of that laying, So generally 300 to 400 wide beams we get according to the span and requirement. And we have done building up to 5 floors with this method. And sometimes if there are larger span, you can use even concrete columns also. So here you can see those concrete columns are there. And this is like load bearing slab, where columns are not visible. And then you can do, of course, electrical part on top, and then you have to lay 4 inch by 4 inch, that is 100 by 100 14 gauge weld mesh on top of it to reduce the hair crack, because the upper layer is just 50 mm thick. So first you just fill the reeds actually. By the time lunchtime happens, and then you take a lunch. So team takes a break, and then you can finish the upper part, which is 50 mm layer. And then you get a very nice bottom and absolutely flat ceiling. By the time this Vastu was happening, and people didn't want a beam. So I took some advantage with that, emotionally telling client, because people were not ready, because they always wonder why this block doesn't fall on our head, So these are the buildings in absolute villages, Like this is a village, Kukana, near Ahmednagar, quite far away from Ahmednagar. But we were able to go there, and with few masons, just 1 or 2 masons, you can see the filler slab up top, which cantilevers outside. And then ferrogami came, So he said that origami is art of paper cutting and folding. So why not we call this ferrogami? And he literally started folding the ferrocement. So here you can see the riser and tread folded, and you can see side part. And then what he will do, he will make a ready-made staircase, like precast staircase. So one staircase is already up there on top, you can see. And this staircase they are trying with a very simple human labor, no machines are required. And then this become kind of ferrocement, ferrogami, and this poured rubble masonry together. So load-bearing walls of poured rubble masonry. So what is poured rubble masonry, I will tell you. But in this elevation, you can see that every lintel level and sill level, you have a horizontal rib. So sill level is the thickness of wall is just 200 mm. So we push little bit at cell level, and you can do electricity there, and at upper part also you can do electricity. So both the thing like sill and lintel becomes carrier of horizontal electric wires, because otherwise it is a stone wall, so it's not easy to chisel it. And then you can see very beautiful housing. This is in Ahmednagar, which happens. So with this folding thing, we started doing a lot of staircases, a slab under the toilets where you need sunk. So otherwise slabs are 200 thick, but when it comes to toilet, then you can have sunk of 200 mm. And because the thickness of good ferrous cement is about 25 mm, you get quite enough space for pipe to go from here to there. And you can see very beautiful vertical walls which are done with this method. So this is one of my best karigar. We developed him in Pune only, Dilip Tupere. Slowly now he's resisting to work more, but we are trying our best to teach his son. So idea is that you push concrete from one side, and then you get this texture on it. And after that, we just put POP punning on top of it. We never use plaster. So all the inside walls are 6 mm thick POP punning. Even the slab on top will have POP punning. And because of that, what happens, and outside also sometime if client agree, then we rub the joints of concrete blocks with special waterproofing glue, and then after that we just paint it. Otherwise you can do that Ahmedabad Dabba plaster, which is hardly 3 mm thick. So all these kind of forms are possible in ferrous cement, which otherwise we kill on our drawing board, because see, centering for this kind of work will be very expensive because it will be just one-time use. And you can see again, this is a Kokan stone load-bearing wall where this staircase happens. We can do very large underground water tanks, and even the slab also on top, because even car parking can happen on top of that. And then of course boats and catamaran. We have this in Mulshi Lake running for last 20 years after V.D. Joshi submitted his papers to government, and government funded this project. And in Mulshi Lake, about 40 villages you can reach with this, with doctors, eye camps, and sometimes you can take vegetables. So all kinds of things can happen with this. So this is poured rubble masonry. You have centering on both sides. Thickness is just 200 mm. In the corner you can have reinforcement for earthquake. So you take, this is an Ahmednagar, and a lot of stone was available because their land bank was of almost 100 acre. So what we did, first we collected all the stone which were lying here and there, and to particular size we cut it, and then with simple labor we started pouring in that. And once that 600 mm height is achieved, we used to pour concrete into that, where cement ratio was very less. And then you get this very strong load bearing 200 mm thick wall, and maybe from inside you can just paint it, or even just you can wash it with pressure water, and it will give you very good results. This is for Narendra Dengre. V.D. Joshi did this Ramakrishna Mandir in Pune. I'm just showing you the potential of ferrous cement, where such a less reinforcement, you can get such a beautiful dome. This was monitored by Bhadas Gaokar. He did this with the help design of Narendra Dengre architect and V.D. Joshi as a consultant. And this is V.D. Joshi's own design for Sahyadri School library. And the person standing below is Tukaram. He was one of his best shagird, to say, but unfortunately died. And after that, we took his son. His son didn't want to do this, but he had about 20 people team with him, Adivasi team, which was trained by Papaji Vishnu Joshi. So we took him and we said that we'll give you work. And luckily till date, we are giving him a lot of work. This is pyramid which I designed in Narayangao. Again, VD Joshi told me that no contractor is ready to this. So, and then I was about 30-year-old. He said, you go and I will guide you. And mobiles were not available. So I used to go to nearby STD booth and I used to call him for any queries. And what particular queries, it was very funny that when we started pulling this 3 folds, of course it was without concrete, steel, just steel folds with tractor, it started shaking like a paper. And I just ran to STD booth and I told him that this is what is happening. He said, we started laughing. He said, yes, this is what I wanted actually, that flexibility. And of course, that was a great learning experience for me. It had 3 floors. This was a wayside restaurant. And you can see the retaining wall also, which we have, is done. Retaining wall is also done from ferrous cement with 60 degree of angle of repose, and still it is there, So luckily we did a lot of views, like when I was very young and nobody was ready to give me ferrous cement work, I started with this dog house for one of my client, Anuj Gandhi. I told him, you have now this small puppy, he will need house, otherwise how will stay, So emotionally he was ready, and he gave me 15,000 rupees budget. And that was enough for me to do this experiment. So through these experiments, I learned actually. This is a wastage, just a fun slide. Wastage lying in our garage, and my wife gave me ultimatum that you use it 1 week times, otherwise I will throw it away. So this is a tsunami chair. This is how it is used. Now this is my son's Arjun's work, where he did this 25 meter by 35 meter dome for Sri Sri Ravi Shankar Ashram, Markar Ashram in Markar. Markar is a very small village near Anandi in Pune. And a lot of work he did there. So this is the first work he started with. I will show you the inside also. Upper part is Kaudi, China mosaic done in lime. And because of lime, it is still working well. If you do this same thing with cement, there are possibilities of cracking because Pune weather is Visham, in the sense the heat and at night cold is at maximum. And then he added this water body. So with the help of R.S. Kulkarni, our great consultant who does this ventilation systems for us, he had a very nice. So here what happens is ferrous cement is a secondary material, and first you have this steel thing, but then topping is always ferrous cement, and all the hot air is taken out from here, and it almost looks like an art piece. When you see, it looks very different. Of course, now all this is covered because of acoustics and all that. We luckily took some pictures at that point of time, so we can share the details with students. Now, this is how it looks. This is a complete folding door which you can open, and from inside you can see that the fan is there, and at the bottom, below the marble floor, we have this radiant cooling. So it cools the lower part of the complete hall, and then because of that fan, it goes up and then it vents out from the upper openings. This is the entry point where my son experimented with very thin ferrous cement. He was trying to experiment that how much thinner one can go. And slowly the team of masons and karigar is improving by daily observation. This is one of the toilet which he did. Even the columns are hollow from inside. It carries the upper water in that tank which is in the center. And you can see toilets all around, and there is a thick retaining wall outside. And between that two, you get this nice ventilation. And each toilet has a different color. So we were experimenting with pigments also in a simple cement. Even housing was done with the same method, 100% ferrous cement. Even the seats, bed, and door jambs and everything was used as a construction method. It is very interesting once you start doing this thing, nothing is impossible. Like this is a hostel building. What you are seeing in front is a male hostel building, and behind is a female hostel building. So they have 3-day workshop, So they come in a bus, and after 3 days they go back, and this becomes the dormitory for them. So the line out happens 3D, You can't make drawings of this. So you make a model, and then you go on site and then sit there for 10, 15 days, and each and every fold you draw. And then this karigar, what they do, they're very expert. So they just sit below the ribs, and we protect it with bamboos, and then slowly that shape emerges, And if you carefully see here, one of the small piece you will see, all other folds are same, but one, so that is given by structure engineer, saying that in case of failure, it will start from there. So all this was a kind of a learning over the period of time. And then you can see how much thin one can go. And again, this has a China mosaic on top in line. This is one of the retaining wall, which is halfway, and another 2 parts will come here. Yeah, so now you can see after China mosaic, building changes completely. And now each this retaining wall, we have clay halfway, and it is grown with the grass inside. These are very early pictures, and behind you can see that water storage tank, which is a specialty of Vishnu Joshi. He developed that complete drawings and know-how for that. So 1.5 lakh liter or 2 lakh liter water tanks we can do very easily in any village. So this is how it looks from inside. Center is a courtyard where we have now a lot of plantation. And this is the tank. All these drawings are done by him. We just redrafted it. So each and every aspect of that is given here. And the lower part has underground tank, which we submerge into land. So it becomes a very strong. And then this, and those 2 rings which you see, they can be 3 also. Sometimes they can be 4 also. So all this we have ready drawings, which is given by him, and the work starts. And the kind of work they do, I say they are not karigars, they are artists. You will see in some next slide. See, now this is a half ball, and now you see, and this is unbelievable. When we see this, we feel so great, so good that we learned it, So they are inside right away, and since this ball with the air, it can go haywire, So we just protect it from all sides, and then this is taken up, and then it is put on top, and again people go from inside. They do rendering from inside, and then they finish it from outside, and then finally it is ready. So you can see lower ball is half inside the earth, and it becomes kind of a foundation. And here it is just single ring, single full ring and half ring, but you can have more because this is on higher plateau. So here height is not required. So with methodology and understanding of technologies, which I learned from him, I started my grids, I started working in grids because 400 mm was kind of a mantra for me, that my blocks are 400 long and I can't have wastage, So we had a half block also, and then you start doing it with a center line. So this is one of the typical plan, 30 feet by 30 feet square. Many levels. The specialty of pillar slab is that you can do work at many levels. And then this is how the building looks from outside. So at this point of time, you have a choice of plastering it or not to plaster it. So in this particular, we actually did double plaster because it didn't have budget. So instead of doing double coat plaster, we had just double plaster. But this is a building halfway. So in nutshell, what V.D. Joshi used to say was that was that first you do go up to sill level, take a break of 1 day, go up to lintel level, take a 1 day break, and then go up to the slab level. And the last course, generally he prefer that you do concrete of 200 because what happens in the way we do centering here, at that point of time, we never had this prop-ups, steel prop-ups which are now available. They used to hammer nails in the last course, and sometimes you used to get hair crack, but now that's not required. So what we do is the last course we fill, we use cavity block and we fill it with the concrete, so it becomes stronger, and then we do the slab on top of it. So this is how building is finished with that double plaster, and you can see ferrocement dome on top, and the circular shaft you see has a kind of wind sucker on top of it, and it rotates with wind, and you can take hot air out from the center of house, and you can see even water storage tank in ferrocement. And even window, we had a double layer, very simple method for lower and middle class people. And I'm very happy about that part of my practice where I actually did practically all the villages, small work, which is not required even to publish it. But every time we learned a lot, and we had a good friendship with them. And it was nice to go to small villages, and the way they respect you as a consultant was unbelievable. So I quickly will show you some small houses, roughly about 3,000 square feet, 2,000 square feet, sometimes even 1,000 square feet. So this is Iyer house. This is in Sopanbag, Pune. You can see a lot of plantation outside. And these are actually kind of 2.4 meter bays, 4 bays. And plan shows an underground rainwater harvesting tank, which is about 80,000 liters. You can see servant room. And on top, you can see a courtyard house with 2 courtyards, 1 puja room on northeast side, and kitchen, and roughly Vastu house as they call. And the upper part has a nice garden with a courtyard, enclosed courtyard. And right above the puja room, you get a nice study. So my client is consultant to some American firms. So at particular times in night, he talks to them through this room, and he's very happy about it. So this is how it looks from outside. To me, the elevation is just the outcome of what happens inside. So I never really try to actually manipulate elevation to do certain things. So this is how it is. This is the main entry space. Everything load bearing. Absolutely no concrete columns. Even the 200 by 200 column is also out of concrete block with filling inside. And you can see even bridge, which is 200 thick. A lot of light. I love courtyards, and a lot of lights comes through from the top. Father's room is very happy that he can connect to kitchen. So psychologically, he's very happy because his connectivity, eye connectivity with kitchen is always there. And then I do certain storytelling in the sense I make a lot of bridge, doing my plan. So sometimes you cross bridge to go to children's room. Sometimes you cross the bridge to go to the library or courtyard, and it becomes kind of very interesting because people hang around there. This is a small dining. So instead of doing those chair around, I have this buffet kind of a thing. So you put a buffet on table, and then you sit comfortably on the sofa, and you can see water right in the center with small fountain. This is one of the bridge which leads you to the children's bedroom. On right hand side, which you see, is a live ventilation. Throughout the year, you get southern wind. So what I do during my construction, I keep spaces in the block 200 by 200, and all the wastage of toilet PVC pipes, I cut I mean, I put it in 45 degree and then cut it vertically. So you get oval shape opening from inside. You put mosquito net on outside. So even if you close total house, you will get wind from there, and from central core, wind is taken up. So I give this kind of openings on top to take hot air out, and at the same time you get nice light also. Even the windows are such that it can control the light. You don't need curtain, but still wind will come in. And this I call Vada window, where you have grill in bottom and 4 shutters, 2 on top and 2 at bottom. So at night you can open the lower shutters, you can close the upper shutter, which complete Pune Vadas they do for last 300, 400 years. And one of the best systems to avoid your grill and at the same time getting a nice, it is a jaruka from where you can look down into another 2 bedroom and you can talk to the people at lower level. And next to the large window, I have developed this 200 mm wide split window with a pivoted glass in it. So with Venturi effect, you will get a lot of wind from there, even if you close the main door. And this is the courtyard on top. Right in front, you can see that study room in the corner and Jula. Behind that, there is a library. And we had a debate on this wall. I told him that after a certain time, you will get 11-story building all around you. And really that happened. And now my client is very happy that we did that wall. And all the trees which are you seeing is his own tree in a very small plot of 4,000 square feet. And it is very unlikely that you get so many trees in such a small plot. This is my first house where I did experiments with light, courtyard, and the footprint, we call it plinth in Pune, was like 60 feet by 40 feet. So you have to do your design in that 60 by 40 feet. So you get 450 as a front margin, 225 as a side margin, and 3 meter on back. And you do nice 3-bedroom house in that. Here I was a contractor. I was so excited that me and my friend was kind of, we were together from first standard. So we had a lot of understanding. So we did this basement also. And yeah, I'm really happy about this. So certain things which I developed here, I'm using it till date. This is that central courtyard with 3 colors, primary colors, yellow, red, and blue. And you can see the upper part where he's a guitarist. So I gave him this room on top where he can go and practice his guitar. And black door is a kind of a pantry. I call it Sunday pantry, where under the shade, now there's a pergola. You sit and have coffee and enjoy your time leisurely on Sunday. And some skylights, I'm very fascinated by the skylight. Here you can see star and moon, together, which moves as sun moves, throughout the year. And then I have the 7 colored lights, like Saregama Padanisa, and those also play, kind of a play on the vertical wall. Yeah, this is Anuj Gandhi. Why I'm showing you this old houses, because here I started to understand the scale. For example, this house is kind of he wanted a Haveli. He's a Vaishnav and he's a Krishna Bhakta. So there is a particular kind of architecture which is done, and here the complete scale is different. Plan is extremely simple, 5 feet grid, and the way we have in Vadas, you can see here, 1500 is a vertical grid. Horizontally, it is like 8 feet and 900 and 8 feet and 900. So those are the grids, and then you have a very high floor-to-floor height. So almost 11 feet is a height below the slab, and you get a completely different scale. And then I had a 5 Krishnas here with the different colors, and you can see how the skylight plays a major role. And again, that storytelling of crossing the bridge and going there. This is like a wind tunnel. From south, I pull the air and goes towards the north. and the railing becomes a seat, and it is used quite well because you can see pouring rain on glass, and you can enjoy sitting here. So this is a scale, and you can see that Jaruka there. This is my very favorite house, just about 24 feet by 40 feet, 10 feet grids, You can see that 3100 grid, and the vertical grid is 3600. And in that, this 2 courtyard house is.
Doshi, sir, sorry to disturb you.
Yes, sir.
Your presentation has stopped. Can you restart?
Yeah, sure.
Thank you.
Sir,
Also, yeah.
sir, can you?
Yes. What are you saying?
Yeah.
Can you see the presentation?
Okay.
Can you see the presentation?
So can you stop? Yes. Okay. Participants can see it.
Yes. Okay. Yeah.
Yes, sir.
No,
So
the
I continue
presentation is
now?
not seen on YouTube. Sir, I
So
suggest you stop sharing and start sharing again.
So I think some participants cannot see the presentation. We would request you to stop the presentation and restart the
Okay.
presentation.
Stop. Okay. Sure. Yeah.
Yes.
Should I start?
Yes,
Yes,
sir.
sir. Please
So
start.
now can you see this? Hello?
Yes, sir.
Yes, sir. We can
So
see.
I will little run through. This is a small house. Yeah. So you can see some. I was fascinated by some houses in Rajkot,
Yes, sir.
Gujarat, and that kind of a white architecture. And this is how it happened. Relationship with sky and courtyards. Transparency from one point to another point. You can transparently see the complete house. So you feel together, and you see some jula and light to, the roof, glass roof on top, where rain can pour, and the central court, some different kind of doors and hot air outlets. I experimented with some housing also, where I did about 10 units each of very different plans. Then I experimented with ferrocement. This is a complete ferrocement room. It's a studio for Jain Joshi, Master Bhimsen Joshi's son. And this is one meditation space which I have given him through the film. And this is a Khadke house where I had this model I made, and then pink is a plot. It is looking towards north, the sea. Road is on west side. This is a south wall, and then slowly you go up, start building, and then you get this wind catchers and turbo ventilators to suck the hot air. So blue is the cold air, and red is the hot air which goes out. And the pathway, I never liked this dog-leg staircase going from ground floor to the top floor. Instead of that, I do this kind of a storytelling spaces where. So this is during construction, and this is how it looks now. Main space, and this is a wind catcher, one of the wind catcher you can see, and it has a closing facility also. And then I have this kitchen which is 16 feet high, and transparency towards main door. The way light plays inside the staircase, because there is a glass on top, and then transparent, room to room you can see during the day. At night you can close the upper window, lower part is open, and you can get a cross ventilation. So some particular rooms have ventilation from all four sides. So in all, it was a very interesting journey. So this is how it shows, glass takes the light inside. You can see turbo ventilator, wind catcher, and even solar energy taken, and even the garden is on top. So whatever land you take, you use it on top terrace. This is house in Nashik, where I started with wind catcher, and you can see the construction technology, very simple, very humble, and the quality of a block and quality of vertical surface is very good. So actually you can get away with the plaster. So some drawing explaining the wind catcher, how it happens, and then you have this house. So it is not that in concrete block you can't do. So very complex, very different designs also you can do with simple building, which is load bearing completely. We have this lime plaster inside from Rajasthan, and no plaster, actually no colors also. Whatever white surface you see inside is actually pure lime, which came from Rajasthan. And flooring is simple Kota stone. This shows the quality of light and how kitchen and other building happens, This is a way to puja room, and then you either take a right or left to go to bedroom, dining area, and you can see the whole building. It's a very long building. Each bedroom gets this nice ventilation from smaller window, and on left hand side you can see Jaroka, which looks into your own house. So this is quite nice. So there is a kind of a street feeling inside house, and you can see the clear story light also, and ventilation also. This is how it looks at night. You can see the turbo ventilators and wind catchers. This is a farmhouse, completely again load bearing in 600 mm thick stone wall, which I did in Mushi. This is about 12-year-old project. You can see the. Yes.
Hello, sir.
Yeah.
So a little slow, sir. We want to see our slides. Yeah.
Okay. No, because I thought it is now already.
No, sir. We want to know, sir.
Okay. Yeah. So I start from here.
Yes, sir.
Okay. Yeah. So this is about 40 acres of land, and they approached me through through my website, and I was very happy that somebody can get a work through website, and I initially never knew how to go about it because land is so beautiful. So I started with this sketches of stone walls, where 600 thick stone wall takes a shape and it encloses building within. So these are the plan. 5 bedrooms is completely covered from the top, and you can see that ferrocement roof over the living, kitchen, dining, and library section. You can see that Titanic balcony where that person is sitting, which is actually a water tank. So we pump water from Moshi Lake and goes up to there. And then I'm doing an institute building for them. So again, that water is pumped further onto the upper land. So this is how it looks, Pune has certain advantage. This is one of the advantage. You just go 40 kilometers around and you get this stunningly beautiful views, And as an architect, you actually doesn't know what to do with this beautiful site. So somehow I managed to do this completely stone building, and you can see some dipsum. So in Diwali they put diyas there, and I said this doesn't require an entrance. The nature has its own canopy of cloud and sky and hills in front. So I need to use that as an entrance. And right hand side there is a living room. And on left hand side, you get this dining, kitchen, and family section. It's a long building. So now you can see how the roof looks. It pours a lot of water actually during the rainy season. And you can see that Titanic balcony on top. Only one person can stand there. It's breathtakingly beautiful from there. We have taken these photos in cloudy weather. You can see the garden on top. And I somehow like the spaces, in between. So what I did between the bedroom and living room, I did this ramp because clients are 70 and 65. So I thought the ramp will be required. And then I did this small amphitheater there where people can sit actually. And it is really working, So there is a canopy on top of ferrocement. The bottom which you see is a vested wood, which comes from the vestage. And now you're looking at east, So I have one east terrace and I have one west terrace. So during the day, you can move from east to west. You can have tea at both the time, one in early morning and one in late evening. So open toilet. This is the view from the bedroom, one of the best view. I just got furniture from Mumbai, old stuff, I don't have ability as a furniture maker or an interior designer. So luckily, sometimes people listen to me and we can stop at very simple furniture. A waterfall in the entry point. It is very peaceful. All these lilies come on a terrace and very peacefully you can go there, kind of. This is inside. And we did some few windows. This is one of the window. On lighter note, this window has my wife's name. I have my son's window also, Arjun and Akash. But this is Sadhana window because it's very complicated, This is Tare Zameen Par, where I did this take on Corbu's lounge chair, and I did this 12 chairs in different positions. You can take a piece of carpet and sleep there at night, and you can see stars on top. That we still do. Yeah, this is my last project, Brick School of Architecture, which is a bit about 25 kilometers away from Pune center. And there's a very nice feeling about it, the way sun moves over it, the kind of spaces and courtyard. It's very peaceful. Whenever I go there, around the building, there are a lot of 11-story towers. But when I go to the central court, luckily, since my planning was inward looking, you get this very peaceful environment inside. Of course, this is a brick leading because in between they thought that name of the institute will be brick. So I took advantage of that and I did this permanent brick finish. I like this front part where no windows are there, but a lot of light inside. This is this central court. Some streets, this particular street we call Vivekanand Street. We have one Corbusier Street also. Courtyard for the library on first floor. Some seats on the sloping roof. This is a south elevation where bridge and the jetting out portion is for the staircase which takes you to the spiral staircase which takes you to the mezzanine level. So thank you. I stop here. So please, if you have some questions, let me know.
Thank you very much, sir. It was really inspiring to see so much, such a large variety of spaces in which you have explored that material, and the idea of the bridge also
You're
was
on
really
mute.
interesting. Hello, can you hear me now?
Yes, we
Yes,
can
yes,
hear
of
you.
course.
Yes, okay. Yeah. We, of course, are waiting for questions from the students and many other, about 100 other guests who have participated. We're very happy
Sure.
that everyone has
Sure.
turned in. Would you like to elaborate upon how, you had these two great teachers, and how did Doshi sir also is very peculiar about working with different materials. How did that influence your work?
Yes. It has a very interesting story. What happened really is that I failed in my first year. I am a student of Abhinav Kala Mahavidyalaya, Pune. This I'm talking of 1974. And then during that 1 year break, I studied. We had this great 5 books of Corbusier, and what I did that I started reading that. My English was bad, but somehow I understood cross sections and the kind of plan, and I fell in love with Corbusier's the way he does space and other things, and because of that I went to Doshi. That is also very funny, how as a child, like my surname is Doshi. Doshi is of course Doshi, great Doshi. So I thought there were, I think, 3 people in India at that point of time who worked with Corbusier. I said, why not Doshi? He wears purple jabba, he had this lenga, and long hair. So I chosen him, and I never knew. When I look back, it was like unbelievable that I chose the best man possible in India as a youngster, And then it was like great 7 years, up and downs. Initially, I didn't get work there, but eventually I got the work, and it was a roller coaster journey where throughout the year you work. During even my marriage also, my whole focus was on Sangat. And we used to sleep under the table and those kind of stuff. And I feel that it's one of the greatest individual architect firm, or master firm. I don't think this kind of more firms we will have. It's not possible, because the way they used to do photography, documentation, continuous plans on one project, 3 plans, 4 plans, 8 plans, And Doshi, when I joined, Doshi was 54-year-old, and I left when he was 61-year-old. So very energetic and a very tough taskmaster. But all that really helped me in doing things, And of course, I learned mainly light and spaces, the way he thinks about it. And then luckily, he told me that you go to Payne to help Vishnu Joshi. Till that point of time, I was not aware. I knew his name, but I never thought that he will be such a great person. And when I arrived in Payne in bus, it was a late night, and I just went for sleep. In the morning, when I show up, there was a skylight on top, and sun was there, And he used to start his office at 4 o'clock in the early morning, and by the time 9 o'clock, he will finish his office. This office means a simple pad and pen, with a lot of papers, and then he will send it to Delhi, and his office is over. And then he will do all kinds of mundane things like buying sabji and making flower arrangement on his dining table, and this kind of very humble things I learned from him. He used to wash his own clothes. So all this frugal kind of great intellectual journey become. Of course, I couldn't go that simple, but at least certain element of that is still there with me. So both have a very different, right? Of course, Doshi had this word view. He used to travel a lot. He will come and share all the stories with us about what he did with Calatrava, what his visit to all these great masters. Sometimes he will give us a pen. And all this, as a youngsters, we had great respect for him, and we all believed in him. And it was like one family working together towards some goal, which is not visible, but everybody knew that in the end, everybody will succeed, And of course, my relationship with Doshi is now 40-year-old, and I'm blessed, It is like showering from top, and I miss Vishnu Joshi now too much, because I was a everyday person in his office and his scheme, His scheme also I have done. So we used to sit there and we chit chat, politics and other thing. And somehow I learned a lot from both these masters,
I think the whole idea of storytelling is also something we could all learn from Balakrishna Doshi sir. In your whole exploration of material has been very fantastic, right from learning from a civil engineer to learning from the most humble of uh, contractors and laborers and workers, and also training them. As students of architecture, what would be your advice on how to learn about such sensitive use of material? The act of learning, how do we go about it?
Yeah. See, I tell you, suppose you take a Purani house, okay, and if you study the Purani house cross section, I have in grandmother's room 2.2-meter high toilet. Above that, I have a study, which is again 2.2 meter, and above that, another toilet, which is 2.2 meter height. So within 24 feet, I have a three spaces, and this is only possible because of Vishnu method. Without Vishnu method, with traditional structural engineer's knowledge, I will always get a 400 thick beam, and all these ideas will be gone. So somehow I was shrewd enough to understand that ki, unless and until I have atmasat this great technology, it is not possible. So I took a design and build approach. So whatever I'm doing is not for technology. So one must understand that it is not for technology. It is for architecture. To me, architecture is prime. But to my architecture, if I require to learn technology, if I require to go on site, if I require to become a contractor, I will do all that to achieve the final result. Because when I look back to my practice after 40 years, I don't want to see a shameful practice, where I have not done that thing. So that, of course, I understood from Doshi in that 7-year training, looking at him. So I think if with these thoughts in mind, you go, I think, as a student, surely you will succeed, and you will be very happy. I have this scooter which I'm running for last 12 years, and I'm not ashamed of it. I go to very deep Rasta pit, and I'm very expert and very foodie person. People ask me for food joints, and I'm very fascinated by that. It is not that architecture is the only area, because to me architecture is life. And if I want to learn about life, I have to go to places where people live. So though I stay on Deccan Gymkhana, which is very elitist area, I go to Rastapet from my school is there, and I grew from there. So I thought that all these things is very, very essential to become architect. Unless and until you understand life, it is not. And of course, you keep your requirement less. Then you don't have to go to many clients. For the sake of fee, you don't have to take work. You can say no to many work, which is very important factor which people don't understand. So I think these are the few tips I can give.
Thank you, sir. Thank you so much for your lecture. It is about 5 o'clock, and we can see Sankalpa sir is already here.
Yes.
We welcome Sankalpa sir, and I will briefly introduce sir at the beginning, and then we will ask him to begin with his presentation.
Sure.
Architect Sankalpa sir teaches at the Faculty of Architecture, CEPT University. His area of teaching focuses on construction and structural aspects of architecture. His design studios are known for making, detailing, and working with modeling techniques. Architect Sankalpa sir is one of the founding members of Thumb Impressions Collaborative, a collective that is involved in artisan-based construction initiatives and has rich experience in designing and building with materials like earth, bamboo, timber, and steel. He has been actively involved since last 7 years working on detailing in bamboo for buildings. He has conducted several workshops at national level related to bamboo for students. His current focus lies on the use of split bamboo as a construction material in Indian context. And rightly so, title for his talk is also Fundamentals of Detailing, a comparative take on bamboo in relation to steel and timber. With this, I would like to welcome Sankalp sir to this webinar and request him to begin with his talk.
Thank you for inviting me. Today, the presentation which I have made, I have particularly focused on that there are a lot of students and sort of how do I make a presentation that is immediately useful to them. So you will find that I have structured in a way as if it's one of the course lectures, and slightly in the end I'll show you some of the images of our work, but largely my focus is to sort of put bamboo in a perspective compared to some other materials so that you are better able to deal with both in terms of your practice as well as studio environment. Can we go next? So the thing is, what I have done for all of you is that I have put some of the images for you to look at it slightly more carefully. And in order to understand one material, it is important to compare with some other material so that we have got some kind of a preceding knowledge in order to deal with it. So if you look on the left side, there is a simple timber structure, and on the right side, if you look at the two images, they are steel. But if you look at very carefully, then you will find that there is a difference between the way the steel is used in the second one versus the way it is used in the third one. And that's what I want you to focus on. So from something which is on the left, timber, which you find as solid construction, on the right, which is a frame construction, but the solid member in timber, you find that similar attitude has been used when you are trying to see the second image. But when you go to the third image, then it becomes the profile that has been used. So just please bear in mind some of these images in the manner in which we are looking at it. We are looking at it from the perspective of tectonics. Next, I have taken some example to show you a way to move forward. So in case, similarly, what I did for bamboo, I am doing what I did for timber, I am doing for bamboo. And if you go next, little bit, I have put it for steel. So what I am eventually doing is that there are two important things which are happening. One is that members, we have to identify members in terms of how they are connecting, differentiating it as bearing and spanning member. And second, geometrically how they are connecting in terms of L, cross, T and all of those. So these two are very critical at a larger level to understand how to sort of make joint. Because in the first one, in the way we sort of classify the structural system, in this case we are saying spanning and bearing, the forces in these members are different, and therefore the articulation will demand certain kinds of way in which you treat certain forces, which will emerge based on the force diagram. Go next. So whatever images you were looking for, we can categorize them at least broadly from a point of view of tectonics or construction into 7 points. The first to look at it is system. Okay, so look at the configuration of the elements, look at the way in which these elements are organized. The second is how is the part and the whole related, which means of course we are talking about the physicality of it. Third is sort of sizes, so member sizes and scale of a building, etc. Fourth is material, and when we are talking about material, what I mean is material is nothing but summation of properties. Okay, so obviously material behavior, etc. will come into picture, and also the morphological characteristics of the material will come into picture, which means the shape and the form will come into picture. And whenever we are talking about material, apart from shape and form, we are also talking about relationship of one material to another material, which means one form of the material to another form of the material, which means one property of the form of the material to another property of the form of the material. Okay, so once we start looking at from that point of view, we go into the force diagram, then we figure out what are the joinery methods and what is the physical environment, which means that expansion, contraction, or sort of vulnerability to corrosion, etc. So when we are looking from a point of view of tectonics, at least we are looking or reading a building from these 7 points of view. So we are so very clearly we are not looking at space. You want me to repeat it again? I'll repeat it again. We are not looking at space at all. Our interest is not in space. We are looking everything from the lens of tectonics, from the lens of construction, from the lens of structure. Okay, and so let's go to the next one. So then what I've done is I have taken the same point and I have compared timber, bamboo and steel. Now I'll not get into the detail of it, but the moment you know one material in a linear assembly, you will be able to compare with another material, because only in comparison you will be able to understand differentiation, and our purpose of understanding technology is to differentiate. It's not to integrate. The role of design is to integrate. The role of construction in the process of learning is to understand, is to sort of differentiate, to be able to later on support design in trying to integrate whatever their aim may be. And therefore it is important that we put our learning in some kind of a framework. Go next. So what is the relationship between geometrical characteristics of bamboo and its detailing in architecture? I'll be focusing on that, because unless until you don't understand this, you will not be able to detail out. And largely that once you understand, apart from property, it becomes slightly easier for you. Now, why geometry is important? Why am I emphasizing this? Is simply because when you are talking about timber and when you are talking about steel, if you look at from the geometrical point of view, you'll find that you will be able to get a uniform section of a timber. Similarly, you will be able to get a uniform section of steel. So it is very easy to get uniform, unless until you want to differentiate it by sort of some kind of a process of tuning or grinding timber or some kind of a profiling in steel. It's all right, but otherwise you can get uniform sections in case of these two materials. But that becomes the change when it comes to bamboo. And once you understand that, you understand the difficulties of detailing in bamboo, and then that makes your life easier, because then you can detail it out. Go next. Okay, so bamboo comes in various sizes, but the point is, right from the bottom to the top, there is a variable diameter in the bamboo. There are only a few bamboo species in which you get almost uniform diameter. So most of the bamboo which you see in Latin America, like Vadua, has got uniform diameter, almost uniform from top to bottom. Okay, so that's the first difference. The second difference of it is that at any point it may not necessarily be that you will get a perfect circle. So when you cut a section of it, as you will cut a section of a hollow steel section, you may get a uniform section in steel, you will not get in bamboo. There is no guarantee about it, which means that across the length there is a variation in diameter, and also at any point, therefore, it is not a perfect circle. Go next. Now once you get so let's look at the hollow bamboo or a solid bamboo. If you look at a hollow bamboo in India, diameter of structure members varies from 7 centimeter to around 12 centimeter, and if you want to cut it, then you can cut the split section. If you cut the split section, you have to know that from top to bottom, because there is a diametrical variation, therefore you will not get a uniform split section. So you will start with one sort of length. By the time you will get to the top, there will be a smaller length of the split section. And the same is true with the hollow or the solid bamboo. Go next. So there are ways in which one can get certain profiles from that hollow bamboo into split. So these are some of the forms which you can get out of it. Let's go next. If you're using split, then you can very well use the tensile property of the split, and you can really create very evocative form. A lot of work has been done in sort of furniture. One of my area of interest has been split, because in our country, we do not get bamboo which are very uniform in sort of sizes, which creates a different kind of structural challenges and more construction challenge rather than structural challenge. Whereas once you go to split, there is a possibility of getting a uniform sections. Go next. Okay. Now there are 4 important things which we have to look if we are looking at these bamboo. One is variable diameter from top to bottom, non-uniform circular section, shrinkage and splitting and straightness. These are the 4 construction challenges which we'll be sort of facing. Go next. Okay, so let's look at the variable diameter. So variable diameter means issues of line and levels is always going to be a problem. Okay, and the issues of connection between 2 poles in widening joint. Once you put one pole and then on the side, if you put the second pole, there is always going to be a challenge. So let's go to the next slide. Okay, so you look at these sections. This bamboo varies around 2 centimeters from top to bottom. Okay, so I have drawn a center line. Now, why I have drawn a center line? Like all other material, it is important in bamboo to sort of work only with the center line. And as far as possible, or let's say in case of construction, most of the part of the bamboo should be close to the center line, because you will get bamboo which has got very also which will be slightly curved, etc. But ensure that it is, as far as possible, it is within the center line, because if it is not, there will be some kind of extra force like bulging, etc., which will work depending on what kind of structural use the bamboo is undergoing. Go next. So now I have placed 2 bamboo side by side, and the second one I have reversed it. So if you look at, because there is a diameter variation, so on the bottom and on the top, the gap is different, which means that when you are detailing out, you will have to take this into cognizance, because you will be seeing gaps. So if you are not used to seeing a gap, there are ways in which you have to do it, which I will talk about later. But the point is, you should know that in the detailing, the tolerances has to be built up. Go next. So what I have done is, now I have put it in vertical, and you'll see that if I am passing a member which is perpendicular, and if I am putting poles which are parallel, then the diameter of the bamboo which is above and the diameter of the bamboo which is below may not be same, or there might be a problem, because there is a variation in diameter as you go from bottom to top in case of bamboo, which means you are showing perfect, like a timber perfectly cut and the timber piece passing. That's not going to happen all the time in case of bamboo. So that's another difference which you'll have to figure out. Go next. Now look at the line, and if there is a uniform section of steel or timber, if I put a leveler, if I put a peg, and then I put a bamboo as compared to steel, you will find that in case of bamboo there will be certain differences, simply because of the size of the way in which the bamboo is there, diameter below more than diameter above, and therefore you will have to, right at the beginning, in the way in which you are constructing it, you will have to create tolerances within the detail. Next. And so if you look at and similarly, if you are going for a widening joint, you will find those gaps as I was talking about earlier, which you will have to take care. Next. Now, non-uniform circular sections, which means that, what does non-uniform circular section mean? It means that if you are trying to think about that you are going to have a uniform joint or a standardized joint for a bamboo, it is going to be difficult. So the problem of detailing in bamboo is that how do you get rid sometimes of a customized sections? Because why customized sections? Because let's say, go next. So let's say you want to connect something, but when you want to connect something, there is a variation in diameter. Now, when there is a variation in diameter, 2 different bamboos are going to connect. The moment you want to connect it, a standard joint for a bamboo is a fish mouth joint. Okay, so you are having a fish mouth joint which is connecting, but for some other bamboo it will be different. For the third bamboo it will be different, which means that in a conventional way you are constantly trying to customize bamboo to bamboo. Go next. If you want to do, let's say, some kind of a joint which is coming at an angle, you will find the same problem because the diameter is not same. Therefore, if you are making a fish mouth joint, it has to be standardized. Sorry, it will be non-standard. Similarly, go next. Similarly, you will find when you are doing a cross joint. Go next. Now, when you are doing an overlapping joint, the only problem would be level difference. So you will have to calibrate your level when you are trying to think about construction. Go next. Okay. You will find in textbook, these are the standard ways in which construction happens. All of these are lashing joints, Many of them will work, many of them will not work, depending on whether you are using in bamboo in case of furniture, or whether you are using in construction, whether you're using ground floor structure, whether you're using G+2 structure. Okay, now why I am saying all of this? Because bamboo usable length you will get in India around, let's say, 4 meters. Okay, which means that every 4 meters you will have to create some kind of a landing joint and think about how it will work depending on what you are spanning or what you are bearing. Go next. Now, in case of India, commonly you should follow a grade of 1.2 meter to 1.5 meter center to center if you don't want to bundle a bamboo. So I've just made a grade, which means that every time in a grade of 1.2 meter, if you will remove it, it will become 2.4 meter. The moment it becomes 2.4 meter, in case of spanning members, you will find that there is a sagging after some time, which means you'll have to do some kind of a compensatory action. So I'm telling you this because generally these grids are not available, so you can use these grids. Go next. Okay. Now the other challenge is that these are typical. Either you are going to have a pitched roof, simple roof, or you are going to have a roof which are four-sided roof. Now each of these roofs creates a different kind of a challenge. I'll talk to you later. Go next. So, but in short, what is important is follow the center line, and in case of detailing, think about that you will not get a bamboo of same diameter. What will you do? These two are very critical. Go next. Okay. The next important thing, if I am trying to find out the center of gravity of steel and the center of gravity of timber for a uniform section, in case of steel, you will find absolutely the geometrical center. In case of timber, you will find a variation not more than 1 centimeter most of the time. And why? Because there is a non-uniform density in case of timber as in case of steel. But the moment you go into bamboo, the density variations becomes much more, which means that your center of gravity will not be your geometrical center. In most of the cases, this variation could go as high as around 30 centimeter, which means that when you are trying to construct a structure, you think that you are treating it like a steel where its CG will be perfect. That would not be perfect, which means in reality, there will be always an eccentric load which is working on the structure. Go next. So if you look at this image, so you will find that generally when you start looking at it, its CG should be at the geometrical center, which means that ideally it will make a curve. The CG will make a curve, but that will not happen if you exactly don't know where the CG would be in these rafters. Which means that we will have to measure the CG, we will have to sort it out in a way that we know specifically which bamboo we are using for what. Go next. Okay, so the most important process for construction bamboo is sorting of the bamboo. Apart from length, you mark all the center of gravity, and then you sort of club it together to figure out that these 20 bamboos have got a particular CG, because then you can start using it symmetrically in case of structure. Go next. So you see some of these. Go next. Go next. And of course, what I was saying that you will have to sort out a bamboo in which almost it lies close to the center line. Go next. There are some other problems based on what species you are using in case of bamboo. So sometimes it would impose where you are using it, because in case of bamboo, you should realize that it demands a moisture content of around 18%. Whereas generally when we are talking about timber, 12% is sort of all right. Which means that if you are using a bamboo from one region to another region, same is true for timber. Okay, then you have to understand, because it's an organic material, there is a variation in climate, therefore it is going to behave. And so it is important that we understand the splitting and the shrinkage of the bamboo. Unfortunately, in case of whatever study has happened in the world right now, we do not have a significant data as far as splitting and shrinkage is concerned. A lot of research needs to go into some of these areas. So I cannot give you it precisely, but it depends on some kind of a conventions which is generally followed. Go next. Okay, now this I will deal with you later, but you see some of the images, sometimes you'll find in close to the knot, the bamboo would shrink. Okay, go next. Then there are issues of straightness, so sometimes you'll have to straighten the bamboo, sometimes you'll have to accept that bamboo is not straight and then therefore derive a form which supports the bamboo. Go next. These are some straightening process. Next. Split I will not cover fully, but I'll just tell you a glimpse of it. As I was saying that the bamboo variation changes from top to bottom. If you will split it, same you will get from the section size of the bamboo. The below section size and the above section size will vary. So will be the density of the bamboo from bottom to the top. Okay, but obviously you can sort of remove some of the material to precisely in case of at least split, you can get a CG right at the geometrical center if you start removing the material. You can also get a uniform section size, but you will have to realize that if you are getting a uniform section size, below you are losing some material. Because what is going to happen is that if I have to sort of draw for you, if I want to get a uniform section size like this, which means that I am sort of removing some of these materials. And why? Because bamboo is a linear fiber. If bamboo is a linear fiber, only at the knots, so for example, in case of bamboo, you'll have to realize that the bamboo strength lies in its circular form as well as strength at its knots. At its knots, the fiber changes the direction and rest of the places the fibers are linear. So the moment you start cutting anything in the bamboo, which means you are removing the fiber of the bamboo. The moment you remove the fiber of the bamboo, you are weakening the bamboo. So you cannot treat the joineries of the bamboo in the same way in which you are treating timber or steel, because the moment you start doing it, the bamboo starts weakening. So the whole trick lies in using the knot, minimum cutting the bamboo as well as using the form of it. As I was saying that I've been working a lot with split bamboo. Let's go to the next part. Okay, so you'll get some of this form in split bamboo. Go next. Go next. Now it is possible to make both synclastic, anticlastic, monoclastic forms in bamboo. The only issue is if you look at the end condition. Whenever in the end conditions, so let's say this is a grid shell. The point is in the end condition it becomes always a problem. So observe this. If we have not resolved the detailing in the end conditions, we cannot get it. The other thing whether you are making a synclastic, anticlastic form, the grid that is worked has to rotate because the uniform grid, when it changes into sort of parallelogram or some kind of a rhombic form, that's the only way you will be able to get this kind of a form. But there is a challenge to it. I will talk later about what is the problem with it. Go next. So I will describe here the problem. So I have been working for 3 years now with some of the split form of bamboo because of the idea that in context of India we have to work because our bamboo we are not getting quite uniform. Now what is happening, and this is where I want to tell you a story where we have been doing as a part of directed research project. So this is one of the thesis which I have been guiding. I'll tell you the failure of it because then you will understand what's the issue with it. So we started working with the soap buffer experiment. From there we got into trying to work out grids in sort of grasshopper. Once we generated the grid, then we went into working on sort of split sections, and then we got into this form. The moment we made this form, we realized, go next. Okay, no, it's not there. So I'll tell you the story here itself. Go back. We realized that and our mistake, I also didn't realize that when we are generating this form in sort of grasshopper, it is an imaginary line which is a cylinder. Now what happens that when we are trying to deal with split bamboo, the split bamboo, if it is this split bamboo, you can only bend in these two directions, which means it can take this form. It can sort of take this form, but it cannot rotate. Now, when it cannot rotate, which means whether I'm making a synclastic, anticlastic, any kind of form, these are anticlastic forms, we soon started realizing that some of the, apart from the grid, some of the form, in order to achieve the form, there will be torsion in individual split. And that we didn't realize, and that's why in the next experiment which we did with one student, we changed the grid to sort of figure out can we change the grid and still we can have a property of the bamboo which is only bending in two directions. We also failed in that. I have put some images of that. Then now we have started working with some of the forms which are possible, which takes the property of the bamboo, split bamboo, which bends only in two directions. So we are working on that, some of these things, and also some of the end details of it, so that it can be industrialized in that sense. Details can be customized and you can quickly do it. Go next. Some of the more experiment we are doing as to how can you engineer bamboo in terms of having perfect sizes, etc. And some of these things I do as a part of student workshop because it's very difficult to get R&D money, and sometimes students workshop in various colleges helps us to do. So this was MSU I did. Go next. Okay, so you see some of the end conditions which has been worked out, that you overlap the bamboo from a single bamboo using split, and then you sort of generate some of these forms. Go next. Some of the images are later, but they are pure sort of tensile structure in pure tensile form. Now, so there are generally three forms which you get in systems under pure compression, systems under tension and compression, and systems under bending. Systems under bendings are very difficult in bamboo because of its low modulus of elasticity. What happens that you are imagining it to be straight, but because of the action of the creep, if you have not worked with enough of camber, you will find that after a few years it will start bending. Much more deflecting than in case of steel or in case of timber, simply because it has got low modulus of elasticity, even in spite of the fact it has got high tensile strength. So you'll find that's why bundling happens in bamboo in many cases also to compensate low modulus of elasticity as well as detailing. Go next. Now other challenges of detailing with bamboo is that if you do a square plan versus if you do a rectangular plan, and if you are making a sloping roof, you'll realize if it's a square plan, obviously this will meet at the center. The moment they start meeting at the center, that detailing is very difficult to resolve because bamboo is hollow. So if you want to resolve every rafter coming at the single point, it becomes very difficult, which also becomes difficult in case of timber. But timber, because there are possibility of detail, because you resolve this junction in a way that you can cut it and you can remove some materials, and then you can allow multiple timbers to come in. That becomes very difficult in case of bamboo. It doesn't mean we cannot do it. We can do it, but I'm just saying. Whereas if it is slightly rectangle, the difference in the two lengths you will be able to see at the top, and so it becomes slightly easier to detail out. Go next. So now again I have come back to these two plans to sort of show you. Go next. Now other challenge. Now as I said that when you are working, so as I have said that, let me repeat it. In detailing starts happening at the corner. Detail doesn't start happening at the wall section. If we are making a generic wall section, and let me this and sort of I'm just making a claim for you. You can disagree with me. Detailing starts from the corner. Generic wall sections are not going to help you, and that is true for all material. But look at it. I'm just drawing it. Now on the right side, you see an image. You see a bamboo overlapped one over another. Because the moment you start working and treating it like a timber, where you will be making half lap joint or mortise and tenon kind of a joint, it's not going to work because we have weakened the bamboo at the corner. Which means that the only way to sort of work out is to overlap the bamboo. The moment you start overlapping the bamboo, you realize that at the corner condition, there is a level difference between the bamboo. So one bamboo is up and one bamboo is down. The moment one bamboo is up, one bamboo is down, which means your slope. So if you are making a sort of a roof, you'll find that the slope here, this direction slope and this direction slope are not going to match. If they are not going to match, because at that point you have got a level difference. Okay. So what compensatory action will you do in order to level that is sort of a detailing challenge. Now there are ways to do it. We can resolve it, but I just wanted to make a difference because that's the difference between steel, timber, and sort of bamboo. Once you start looking at the corner conditions of detailing. Go next. Okay. Now let me get into other challenges which you will be facing. So I have made a conditions of the corner where I have got 4 bamboo, 3 bamboo, 2 bamboo, 1 bamboo. Okay. So these are the conditions in which you will be working. So 4 bamboo. Imagine a 4 bamboo and imagine a walling material. How will you resolve that? Because one, there is a variation in diameter, but you will have to think about the way in which all these variation in diameter are going to come at the corner. If you are using a single bamboo, then you will have, let's say, wattle and dog. Anything you will do, imagine a standardized material versus a non-standardized material. Because your bamboo diameter varies from bottom to top, if you are using a standard material, there would be a gap at the top. Okay, how will you deal with it? So similarly, if you are looking at 2 material, what will you do if you are looking at 3, if you are looking at 4? So I've just made a conditions for you to think. Now, obviously, the 4 one becomes the most convenient one simply because you can cross members easily. Okay, the more you drill the bamboo, the more weaker it becomes. So apart from bundling of the bamboo to take care of low modulus of elasticity, most of the structure you'll find bundled also because different directions comes there. It is very easy to detail out when there is a 4. 3 is slightly difficult. So I have put all the combinations for you right now to think. Go next. So 4, 3, 2, 1. If you'll see from a point of view, if the rafters are coming, you will be able to see these conditions. Go next. Okay, and in sort of, if you look at sectional elevation, if it is 4, you will see this. Go next. If it is 3, you will see this. On the right side one, what I have drawn is a difficult condition. So I have not drawn for you, but it's a difficult condition because of the slope. Go next. If it is 2, these are the 2 things which are possible, which you can do. Go next. Okay. So I'll sort of quickly move away from this, our physical and mechanical property of bamboo, because I've already talked about it. Go next. But you can see on the right, you see density modulus relationship. If we are looking at bamboo, there are 3, 4, or if you are looking at any material, at least architecturally, there are 2, 3, 4 properties extremely important for us. Density, modulus of elasticity, thermal conduction, and thermal coefficient of expansion. At least if we know these 4, we will be reasonably able to detail out, because rest of the help we can get from engineers. Go next. What are the ways in which joinery and junctions are resolved? Go next. You have selected a proper bamboo. I will not talk about in India what are the bamboos. Go next. Okay. These are the rules. If you want to follow, it will be easier. Identify detail as a diagram of force. So for you, I have made this model. Okay. So if you look at this model, okay, if you look at it, I have diagrammed this force. If I want to do it. Now I have to perpendicularly apply the force. Okay. So if I am applying the force, I have to figure out this member is in compression or tension. If it is in compression, you require greater moment of inertia. So you require materials which are spread across over the center line. And if it is under tension, you can afford to have a thinner material. Of course, when you are having a thinner material, the point is that if there is a reverse force, then it should little bit work for compression, and therefore we don't use cables, we use pipes. But anyway, once you diagram the force, identify details as a set of property between 2 same or different materials. So which means that we have to identify density, we have to identify coefficient of expansion, we have to identify thermal conduction. Okay. Now why we are identifying all of these? Because these are directly going to affect the way, and of course modulus of elasticity. Okay. Once we do it, identify the tolerance of each material towards other. Tolerance means obviously apart from coefficient of expansion, I told you that tolerance has to be built in detail, because if you have got two parallel bamboo and you want to now have another bamboo, not only level is a difference, but diameter is also a difference. So how will you take care of all of these? Identify the geometry of the parts coming together. Obviously, you have to identify the morphology, then sequence of construction and skills and tools. I'll not get into it, but these are the stages of the detailing. Go next. So you will have to identify dimensions of the connecting parts, required dimensions as per the structure, identify the material with respect to exposure conditions. So whether you are doing it inside or whether you are doing it outside, materials are going to behave differently. Identify morphology, sequence the assembly, decide elements of emphasis. Decide elements of emphasis I have simply add because you will be anyway talking about its expression. But I just wanted to subdue, so I will not talk a lot about it. Detail as mediator, detail as negotiator, detail as, you can look at detail in a multiple way, and therefore the expression. Go next. So these are the diagrams that has been made out of the course. Go next. Okay, from these experiments, go next. Okay, once you do it, you arrive at the grade because of the force. Apply the material. The moment we apply the material, materials are nothing but property of that material. Go next. And then detail out. Okay, I will not get into too much detail because you will ask me later. Go next. 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 So I have said that there is a great change, etc. But the great change also has not helped. So now we will go back to an R&D where form and grade we will work together in the script as well to say that there is only sort of flexibility in two directions. Go next. Go next. Next. Again. So I was talking about this pure tensile force. Tension, tension, tension. So an R&D on that. Go next. So struggle for detailing is to deal with questions of in case of bamboo, apart from all what I talked, standard fastener for a variable diameter and shape of the bamboo. Because it's very difficult to customize all the time with fish mouth joint. What would be the standardized detail that would evade the variation in sort of diameter? One of the ways to do it is to insert a member inside the bamboo, and that's what most of the people do it, and fill it with mortar or not fill it with mortar. So that's the first image. The second is flexibility, flexible fastener. Flexible fastener means what? You are lashing it. Because why you are lashing it? Because the lashing is adapting to the variation in diameter. And the third one is customizing, where every time you are making a fish mouth and you are customizing. Once you know all the three, you will be able to detail it out. Go next. I will not talk about this because there is slightly limited time. But we have to also understand to be able to draw does not mean to be able to make. Drawing aids construction, drawing is not construction. Okay, and so therefore, if you look at these are the 5-7 principles of construction. Datum, line and level, marking, jigs, sequence of construction, the shop and the job work, coordinating, collaborating, mediating, construction detail, and preparation of materials. These are construction. Drawing is not construction. Drawing aids to construction. If we don't know this on the site, we will not be able to construct it. So I'm not getting to detail because we can take a whole sort of series on this. Go next. I'm showing you some of the image, how people are doing it. So little bit help of pin as well as little bit help of lashing. Go next. Okay, which is done in this building. Go next. Okay, in this case, if you look at the landing joint, there is an extra bamboo which has been added and that has been expressed. This is part of the R&D which we are doing for Bijoy's Melbourne Pavilion, where we were bamboo consultant. Go next. Okay, you start seeing, now here I will little bit talk about washer. This is a work done by Simon Weil. It's very important to know this. So normally what we are doing is we are using typical washers which are available. Okay. Now what happens that bamboo is linear. So the moment you start applying torque on it, it starts further splitting it. So you cannot over apply the torque as what you do in timber or in case of steel. So you should know how much you have to apply the torque. Now what this washer does is you are applying the torque, but this washer is saddle shaped. So what happens? The split is, so the bamboo is trying to split, but the saddle is trying to hold it. I found one of the most innovative work that has been done by anyone as far as bamboo detailing is concerned. So I mean, there's some of the best work in terms of detailing where somebody understands material property, and therefore a small innovation in a small thing really does a revolutionary change in the way in which we detail our bamboo. On the left, I have put out the conventional stereotype way in which people do it. Personally, we do it sometimes also, which is a false nut. But it's not the best practice. Let me tell you, we have not been able to, our industries have not been able to manufacture this. We have been trying to push for it. Go next. Okay, so as I was talking about, every time you are using multiple bamboo, each bamboo is doing a specific task. Okay, because the more you will drill a bamboo, the more you will weaken the bamboo. Next. Okay, you see bamboo converging. You see on the right, which is detailed. This is where you are compelling bamboo to sort of customize itself into a standardized detail. Okay, and same on the left is happening where somebody has used a steel detail to customize, to standardize bamboo, which has a varying diameter. Go next. Next. So some of the more details you see next. Same, you sort of find out some of the details I'm showing you. Okay. Next. Next, again, the right side I think is similar, whereas on the left you see basic detail, obviously. No, I think on the right, I think it's a German, if I'm not wrong. I'll have to check. Okay. Shanghai, I'm not sure about it. Go next. Yeah, some more ways to sort of work out. Go next. This work we did for Bijoy, you might have seen Melbourne Pavilion. We were bamboo consultant to them for detailing and all of the work, and Overhook was the engineer. So I will now quickly go to just show you some of the work, and you can then ask questions. Go next. Next. Some more details if you find sort of expression in bamboo which is possible. Go next. This we did for Jwalanti's and Black Studio. So obviously at the corner we suggested to use timber, but rest of them are all bamboo. Go next. This we did for Samuha Group in Kochi Mujris Biennale, again detailing. Go next. Okay, so you find that we have diagonally put the vertical member and then we are articulating it. Go next. Next. Some of the works which are coming up, go next. Next. So we're doing some of these work where we are now going for large span structure. So this one is around 9 meters. We are now going for around 22 meters. So by next year, you will be able to see a lot of new work which we are doing, which will come in as far as bamboo is concerned. Go next. Yeah, and some of the detail you sort of see, we are trying to customize. We are trying to use standard element and customizing or working with variable diameter bamboo. So what would be that mediating detail we are trying to work with? Next. Next. So you'll find on the right above, so one of the details which we are doing, where if the diameter variation is from, let's say, 7 to 12 centimeters, that saddle, what should be that customized saddle and how much its sort of length should be, that it should be reasonably able to cater to variation in diameter. So we are just trying to work as far as possible to standardize detail. Because once you start, especially in urban areas, once you start doing customized, the cost is going to increase. Okay, so that's what is happening. So that's, I think, go next. I think that's where I would sort of end up. If you have any questions, please feel free to ask.
Thank you very much, Sankalpa sir. I think it was a very, very detailed way of looking at one material and understanding it completely, which I feel is very important as students for everyone to understand. We would now like the audience to ask their questions. you can post them on the chat box available in the Google Meet. And also we have visitors on YouTube. They can post their queries on the YouTube link and they will be conveyed to us on this meeting link. One question I would like to ask to begin with is, in India, we have a variation of climate throughout, and can we use bamboo in all climatic conditions, or there are certain limitations? And also, are there some treatments available which will make it usable in different climatic conditions?
The second part I didn't get. Are there
any treatments that are available for bamboo?
Yeah. So, see, the thing is, as I said, that people have been using bamboo. I mean, many of the places, Assam bamboos gets in, or bamboo from Madhya Pradesh gets into it, Karnataka gets into it, or let's say from Konkan gets into it. Now we have to just understand that sometimes in dry region you have to create a water body nearby, because if you not have some water body, the sort of your moisture content is sort of a tricky thing. Now, what you need to understand is that as far as possible, so whatever I have documented bamboo as old as 50 years houses. Now, the issue with some of these is that the bamboo generally performs poorly when you are using in bearing member which is outside. Because if you are using bearing member outside, then it is continuous under expansion and contraction with sun and moisture, etc. But if you are using in roof, it really lasts. Okay, or if you are using columns which are inside, it will last. Okay, provided you separate it out from the soil. Okay, so that's the answer to the first one. The second one, as far as possible, yes, please use treated bamboo in some or the other way. So if you not use treated bamboo, then generally, if you are using a non-treated bamboo, then in your own region that bamboo will work. If you are using bamboo because it will last, but still you should treat it in some or the other way. There are treatments which are available, borax, boric, or CCB treatments. All of these are available. If you are in sort of Konkan region, Convac does it, or there are centers in Nagpur that does it. So depending on which part of the country is that, you will get people who are treating bamboo.
Thank you,
Sankalpa sir.
Sir, can I ask Girish Doshi sir also to come online, and we will have a joint panel session.
Yeah, I'm there.
Yes, thank you, sir.
I just want to say I have no words for Sankalp. It is mind-blowing learning experience, especially for me. Thank you, Sankalp.
Thank you, sir. I mean, we have been learning from you since now, I think 10 years, 12 years, or I don't know how many years.
Yeah.
So I would like to ask one question, Sankalpa sir, to you. Like, if we make a bamboo structure, what is general age of the structure in India? Like, if we make in India a bamboo structure, what should be the age of that structure?
Yeah. No, bamboo structure, you're saying bamboo, selection of bamboo you are asking?
No, sir. If you are making a bamboo structure, like we are using material as a bamboo and we are making any structure, so what is the age of that structure in India, in Indian climate?
If it is treated bamboo, it could go 40, 50 years.
Okay.
Okay, even more. As I said, in the roof, if you are using treated bamboo, I don't know how many years it will last. Only in bearing, it might have slight problem, because I told you that I have documented bamboo 50 years old in the roof.
Thank you, sir.
Hello, sir. I have a question for Girish Doshi, sir. So first of all, it was a really insightful lecture which we received from both of the people we have here for sharing their experiences. And I feel very privileged that I have also visited your Girish Doshi sir's structure when we last came to Pune. So my question is, like, your major material which you have used is ferro cement, ferro concrete. How do you maintain the quality of construction and the quality of maintenance, as it is very important in case of ferro concrete?
Yeah, as I told you that I was very lucky to have Girish Doshi as a mentor, and during his days in Pain, that is a small village where he spent 14 years of his life to training Adivasi people, and luckily few of them have survived with us, were directly trained under VD Joshi. So I thought that is one reason where we can inspire the next batch of people who are working on ferrocement. So, very close inspection and a very close relationship, because you can't treat them as a worker. They are like, as I told you, they are like artists. So we have to take care of their emotional needs also. So we have to be very careful on site while speaking to them, and that we are doing for many years. So I think that is the one reason where we are getting fairly good quality. I wouldn't say it is extraordinary, but it's fairly good quality.
Thank you, sir. I have another question. Just
Sure.
like it is like we have like you spoke about ferro concrete and Sankalpa sir spoke about bamboo, but then with respect to sustainability, it is always, I don't know if it is a misconception or something. So it's like concrete is a less sustainable material than bamboo. It is said so. So I wanted to know what is your take on that.
Yeah, it's true, I think. Unfortunately, when I started in 74, the aspirations and probably understanding of the world as far as sustainability and other things concerns were not so much there. Sankal's generation is, I think, very lucky that they are in a generation where all this matters. And he's talking about a real thing. So many times I think what now things are happening all over the world, kind of research which is happening is very important. And me myself also is learning, and I'm on that path to go in that direction. So surely what Sankalpa is doing is extremely important, I think. And I think it's very tough also. It's not easy. Let me know the kind of drawing he has done. I know how much thinking and understanding, and especially that pavilion he showed for in Australia. I think it's unbelievable. So I think this kind of research are very important. And of course, at the same time, ferrocement also is possible, so as a possibility. So yeah, I think.
Yeah, let me respond to it. I think when Girish sir was trying to practice, it was a time when concrete was celebrated. So his work you should look at exception to that, because what he was doing is he was using as less as possible in the most innovative form as possible, where you are not using form. If you look at from a point of view of cost, if you look at from the time in which that practice was happening till today, then you will be able to see that during that time he was almost like a sort of taken apart, which was not mainstream, in spite of the fact that he was using some mainstream material and his expressions are quite modern. So, and if you look at, I mean, I've been looking his work from all of these point of view. So I realized that there is this coming together and converging of all of these, where he's responding to his time, but at the same time he is aware about the context, about the artisans, and about the knowledge that is required in order to address our challenges. So you see that he's a shift from Doshi. See the thing is, Doshi being in his time, if you look at the modern movement and all of those, the celebration of concrete, that it will really change, the influence of Corbusier. But somebody who has worked with sort of Doshi, but he has a slightly different take on it, in spite of the fact that there is some kind of a rhythm when you start looking at his space. Okay, so it's a wonderful combination I can sort of see when you look at his time, okay, and what he's sort of trying to do right now. When we've started practicing, then obviously we'll have to see that our generations were practicing when ecological crisis already started happening. I mean, there is no denial now. I mean, you cannot say that if you're going to make 100% building, you know that in concrete you're using the most destructive material on this earth to do that. You want to take that responsibility, take it. We don't have any issues with it. But anyway, let me add the component of sustainability in a slightly different way. Look, I don't think that we will be able to 100% remove concrete. My take on this is that wherever it is required, please use it. Okay, I'm not saying that, but we have to be. What are the new challenges of our time from a point of view of sustainability? To me, the new challenges are will you be making a detail now which would use less compost? Will you be making a detail which would use less sweet water? Okay. Will you be making your construction process as well as spatial resolution in a way that is quick to construct? I mean, there are multiple challenges. Will you be making the last one? Will you be making a sort of a construction system that is more plural, that gives employment to a large amount of people instead of encouraging only industrial modes of production like concrete? So there are multiple challenges which we have to take in our own time. So even if I ask you that calculate the amount of detail in terms of water, okay, in your building, then you'll come up with enormous amount of water you're using. I said that, okay, that's not feasible in terms of today's time. Okay, so our time has to address our question, provided we know our question for sustainability. And therefore, I think that we may not be 100% successful, but in smaller ways we have to try. That's what I rather put it, rather than and sometimes being pragmatic, because you'll say that flyover and you are using bamboo. I don't think that is going to help you out.
Yeah, and another thing here, which is very, very important, when I reached V.D. Joshi's place in Pay village, this uneducated Adivasis who every night used to drink, and V.D. Joshi become kind of a activist in a way of changing their life completely, So I think going to grassroots level, rather than sitting in an air-conditioned office and talking about certain things, it is necessary for us to go to grassroots level, and that is what V.D. Joshi could do. And that actually really touched my heart when I was very young, and I never had this angle, because you are in a very comfortable life and you don't understand certain things. So I think what Sankalp is doing is, in that sense also, is extremely important, because he can reach to all the villages in Northeast or wherever bamboo is easily available. So same thing I did with ferrocement. I went to villages, To me it is also city material, but my focus was all the lower middle class people in the villages. So I think this angle also matters a lot.
So there is a question on Google chat. Is the heat gain of ferrocement more than conventional brick?
Yes. It is quite a lot, and for that we use certain techniques like putting the China mosaic on top, and the height of the room, and actually cross ventilation and getting hot air out from the upper level becomes very, very important. So still I will agree that it is quite hot, and we are working on it. Certain chemicals now are available, which we are trying, and yes, we can actually can't make it completely comfortable, but because of these factors, it is reasonably good, till now we don't have complaints actually in this all large scale building, because height is so much, really. So yeah, but one has to work on it, I'm sure. I mean, that is one problem we have to solve.
Sir, there is a question from the YouTube side, like in the link. So it's from Himani Pawar. She asks that you are working on a formatted, like Doshi sir, you are working on a formatted grid. So we usually get influenced by it that the design becomes monotonous. But then still maintaining the primary grid, there is a uniqueness in your design. So how do you achieve that
I
in
think
every space?
I think you have to simultaneously work in cross section, and as I told you, the life, it is not just about grid. Grid is one part where your structure becomes simpler because my module is 400 by 200, and I have to justify that module. And at the same time, when you work on a cross section, as I told you, because of Vishnu technique, I can get 220 as a height without beam, with a flat ceiling. So all this actually works for advantage. And see, one step by step, you have to go ahead. Suddenly I can't make building which is curvilinear, or because I have to first finish one part of learning, which I'm learning for last 30 years, and it's not enough, because I think architecture is a very difficult art, and I'm trying to test myself and achieve, out of this techniques, whatever I have learned, and if I can go really further towards the direction of other kind of architecture. So I think it's a very slow process, and yeah, someday I will try to reach there.
There is a question from Kalpak Surve. He asks, what do you think drove your curiosity about ferro cement, ferro concrete? How does economics play a role in ferro concrete construction, as the cost of labor as compared to other constructions is higher for ferro concrete?
My curiosity is because of, as I told you, V.D. Doshi. In 1980, I met him first, and I never left him because he's from Pune. And another thing is that he used to get very angry when somebody would ask that ferrocement is expensive, not expensive, because a certain thing which you can do with ferrocement, you cannot do anything with that material. No? So there is no question of comparing what is the labor and all things. For example, as I told you, that Ramakrishna temple, the cover on top, so in what other material, as I told you, the cost of centering itself will take away the larger chunk of money. So I think these questions are related, you can't give a direct answer to this, so one has to work on it. And certain, like I showed some spiral staircases. So of course, ferrocement becomes very easy to do spiral staircase. Otherwise, you have need a lot of centering and other stuff. So in that sense, with normal construction, there is no comparison. Yeah, and that's the beauty of it. That is why one should keep doing it. Otherwise, it will die because it is quite a lot labor oriented or karigar oriented. So as I tell, like those karigars are really artists. In case of Sankalpa also, the way bamboo is used is actually, to me, I got a goosebump. It's like an art form. When you see 3 bamboo, 4 bamboo, and the way diagonally roof goes into it, it's absolutely art.
Sankalp sir, can you also inform us how did you get interested to explore this one particular material? You have been doing this research since the last 7 or 10 years. So what drove you?
Yeah, see, the thing is, I've been always, let me put it this way, accused of working with bamboo, if I have to put it that way. But the thing is, I have been now working with most of the materials. So most of the materials simply because one, that I am continuously teaching construction. So once I have to teach construction, for me, bamboo is another material like steel, concrete, timber, or let's say some other materials. Okay. But what happened was that when I started practicing, before that I did a little bit of work in villages where we were making bamboo construction, and I was working with artisans. And during one of the flood affected areas. And so once I came back again after working to set, apart from all material, I also introduced bamboo in teaching. So what I did was, earlier in teaching, what used to happen was, and some of our other colleagues also supported. So the curriculum was based on that. In first semester, you will do brick and timber, and then steel, and then concrete, etc. We said nothing doing like that. We said that the materials, if we have to classify, are based on the way we sort of construct it. So there are modular construction, there are linear assemblies and things of those kinds. The moment you do it, you free from the name of the material. Second, we introduced this idea of materials as nothing but property. Now, the moment I use it, then I say that, okay, if it is casting, let's say, so you can do earth in terms of casting, so you can do lambda, you can do adobe, etc. You can also do concrete. So which means that the moment I use this term, the material palette opened up. And that is free, I would say, free your time from the historical burden of trying to separate out material and look at it. Because from our duty as an academician, I cannot say that the bamboo is a good material. I can only say that these are the materials, these are the properties, this is how it is explored. When I'm doing a practice, we have been doing a lot with earth, lot with CSCB, timber, bamboo, steel. We do a lot of work with steel, and we are increasing because of its recyclability value. Okay. In fact, in my studio also, we do a lot of exploration in teaching with timber, steel, and bamboo, and all other material assembly construction. So I would not say that my interest in bamboo is really one thing. I have a general deep interest in construction and structure. So I really love what he showed. For example, I get really sort of taken when I see intelligent work and intelligent use of construction, because that's very difficult to see. Intelligent detailing. You're searching for something which really think that, oh, that's what you have been searching for all your life, and you see somebody has done something simple. So I get so much pleasure when I looked at and I understood in my own way Simon Welles, that washer. We see that we detail from a nut and bolt, and you see somebody does such a phenomenal work, because that work is a revolution of his time and of our time. So I'm interested in detailing. And why bamboo more? Because bamboo is a challenge, because you see it has got so much problem that the moment you don't discipline yourself with respect to bamboo, you cannot detail out. Steel is easier for me to detail, and timber is extremely easier for me to detail. The same is concrete, but bamboo is very difficult for me to detail, and that's why I got one more step ahead to say that, okay, if it is so difficult, let's take it up.
I have a question, if I may ask the audience.
Yes, please go ahead.
Yes, my question is for Sankalp sir. This is an academician's question. You will understand. Whenever we are in the academics, we teach on the board and on the drawing board. But when it comes to working hands-on and constructing an experimental structure, it takes a lot of time, effort, manpower, money. So I would like to know, there is this one example that you've shown where you use grasshopper tool and you constructed a tensile sort of a membrane form in bamboo. Could you explain how did you manage that resources aspect of the experimentation as it is an academic activity and research activity?
Okay, see, the thing is, so I will tell you the early parts, because this is a late in sort of the career where this is happening. So early part is started happening when we started exploring Japanese joinery, because we started exploring Japanese joinery both from a point of view of force, but also from a point of view of visualization, because it's difficult to visualize when you see drawing and when you have to really make it. And so I started learning by working with the students. So the attitude was very clear that they were working and I was also working, because obviously you are interested deeply interested in construction. So you start with lesser resource, and that student were able to afford, because those were not expensive. We have to use smaller sort of PA. And to begin with, I started sitting in workshop. So when in the old CEPT workshop, I used to sit and work with the workshop in charge, workshop technicians. And that time I took over as the workshop in charge from architecture, and sort of I spent a lot of time with carpenters. Of course, he has passed away a lot, but you know, see, the thing is, what I realized is, and also on the side, that once we lose in the early years ability to gain that courage is a very difficult job, and that we have to gain in our early years. So doing something. So once I sort of returned back from the site, I joined the workshop, and then in first year, what I used to do it, I ensured that I said that like all our students has got your mechanical pencil and your triangle and your parallel, etc. In our class, we will have carpentry tools. So every student, since I think all the batches, except now the system has changed. So before a couple of years, all my batches had got their carpentry tools, basic. And we used to ensure that we used to work. And so in the first semester, we used to do smaller work, which we used to call prototype. In the second semester, we used to do 1:1. So whenever we used to do 1:1, little bit we used to ask CEPT to give us fund, and some we used to contribute personally a little bit. And then the idea was that whenever a student will make anything, it has to be poetic, it has to be good, it has to be pleasing. It shouldn't be like, oh, you have made an art and then you are putting on a Facebook, etc. That's not. The thing is, whenever we are doing it, we are doing a professional work. We should not say that, oh, it was a student work and that's why we did it. So we pushed ourselves to do some of these things which sort of help to, and the other thing is, within the time which you have got, officially you cannot do making of these kind. You have to spend double the work at the back, because I have to train the workshop technicians. I have to ensure that they are present. I have to be present all the time. The pre-work is a lot when you have to do 1:1. But maybe sometimes I'll show you the work which I have done with the students as well sometimes. So the point is, you pre-plan it, you do all of these, you do baby steps before sometimes you start getting a little bit of fun. So many of the R&D I did because once some of the colleges started seeing that this chap is sort of doing all of these. They started, can you do 3-day workshop? Can you do 5-day workshop? And I said, okay, whenever I do a workshop, I will do something new. And now what then started happening, bamboo was so cheap that everybody said to me that, okay, can you do a bamboo workshop? And that is how, because I am so much interested in doing steel and timber, but who will afford that? If you understand that. The other thing which we are doing is modular blocks, but modular blocks, so we did that twisted column, twisted arch, all of those. That requires little more resource. But by that time, CEPT started giving us little more resource if we request it. So it's not so easy, but if you are interested, it started happening that way. And then of course, then our practice started becoming bigger, and now it's a seamless thing. We do a lot of R&D in our practice as well, because our team are absolutely hands-on people.
So there is a different and interesting question from a student, Ritika Lelan. She is asking, is there a possibility that bamboo be used as a replacement or as a reinforcement material in concrete construction?
Yeah. So this has been worked a lot earlier. You can use it, but the cost of construction will be huge, because the compensatory action that you will have to do in order for bamboo to not absorb the water of the concrete, okay, because it's an organic material, requires you to coat it. And once you start doing all of this, its cost becomes so much that one should not use it, simple, unless until we find a cheaper way to do it.
In this view, do you see a possibility of a large-scale use of timber and bamboo even in urban constructions like pre-laminated timber and other ways of using bamboo?
Okay, so we should know that in Europe and in America and other countries, still people tremendously use timber. Okay, but the point is they have made timber forests, whose purpose is that they will cut it after some years and use it. So there is a whole material chain which is available. We don't do it. Now, so for example, Canada is now making high-rise in timber. They are trying to do all of this. It's not, remember one thing, what they are doing it, we will do after 20 years. Okay? Because we don't want to, I don't know how to say that, we don't want to work, we don't want to move ahead of time. So we want to catch the same train in which they had the problem. So we will be taking the last bogie of the train in which they are sitting in the front, simply because we are waiting for somebody to tell us, but we are not ready to cut short our time and really move at a point where it is required. So believe me, once we will be in 30 years down the line, we'll be doing the same thing what they are doing it, but right now we don't want to do it. Okay, that's our civilizational problem. I don't want to discuss that. We want to repeat the same historical mistake because we are waiting for the train that will never come. So to say that we have to do as far as possible in smaller ways till. See, the thing is, if you look at from a point of a generation, I don't want to take a responsibility in 40 years down the line to tell me that somebody was not intelligent in their time to look 30 and 40 years down the line as to what was happening. I don't want to take that responsibility. If Concrete Fan wants to take that responsibility, let them take that responsibility. Okay, because the new time demands new language and we have to stand up to the time. If we are not standing up to the time, look at the textbook, do what Corbusier has done. But Corbusier was responding to his time and he was right in his time. I'm not fully aware about the floating bamboo houses, but principles of flotation is what works, which is simple science. Okay, that density, if you look at the density, if it is lighter than water or sort of P and second is the form of it. So that's the logic of it. Rest of the things I don't know, so I'm not responding to it.
Yes, so I think what you mentioned about Girish Doshi are also looking at the same material and but working with it in a completely different and new manner and a very exciting manner to probably form a new language for a changed time. I think that is what we could possibly all aim for. There is one question from Himani Pawar. While working with bamboo, it isn't possible to make working drawings due to size variation. Does it make the presence of the designer on site mandatory, or are there other ways to work around it?
Yeah, that's a very good question which he has asked. After a long time, I have seen a good question, and so which means that the detailing which we are doing in bamboo has an inbuilt tolerance of variation in diameter. Now, so it means that when you don't have variation in diameter, you don't have to worry about it. So your detail has to take care of what will vary first. Second is, ideally when you are trying to execute it, obviously I said that you are only working with center lines. So once you are working with center line on site, you will train them to sort out the bamboo to sort out in the way that length, CG and diameters are all properly sort of put in. Once you do it, then you identify which of them bamboo will be used at what part. Okay. Once you do that, then you figure out that how many details are there. Now, once you know all of this detail and once you know the materials you are there, then you mark it out that if you have that, mark it out in the sense that if you are not on the site, then you work with a detail which can take care of your tolerances, so gaps and things of those kinds. I mean, I didn't tell you, for example, let's say this is a typical single bamboo. Now you have got a rafter here, okay, and you have got your furnace and you have got your sheet. I didn't ask you the question that if bamboo is bearing, how will you level your sheet? Okay, and if you have not thought about it, you have to only use material which is traditionally used, which is thatch. The other thing is if you have to make it completely packed, look at the plan. the gap between this, there will be a gap between this. Every rafter in between there will be a gap. How will you sort of pack it? What is the detail for that? So the thing is, that's why it makes it difficult. If you have resolved some of these things, then quickly you will understand the purpose of working drawing. And frankly, it's a good question because we do minimum working drawing in bamboo. We do basic, then we know how we'll take care of it. So now we know where the problem will actually happen. And you know, if you look at the lecture, I have only told you where the problem is. And once you know where the problem is, you will realize that it becomes very easy to deal with all other materials. Okay, because all other materials are standardized materials. So just to respond to sort of your working drawing is important, but you should know there's a difference in working drawing because these things are different. So if you have work, you will take care of it and then release the drawing. And your artisan should know that. They should know how to use knot, how to use that extra length, all of these. So, and I have been telling everybody, working drawing is not construction for all the materials. The knowledge, see, you release a drawing, but so let me say that I will release a drawing and give to other architect. Can they make it? No. Because the knowledge of construction is different from the knowledge of producing drawing. Though there is an aid, you know it. So unless until you have worked with it, you will not be able to make a proper working drawing first. And second, even if you make a working drawing, you will not be able to construct it. Because construction knowledge is different from producing drawings.
Yes, I think that's a very important question for all students, for all students to remember, because as soon as you step into practice, and many times with an experience of not having made large-scale models or worked with materials in school, this problem might arise. So I think we all will need to be very careful about it. As students, it's, I think, a very important point to understand.
Thank you, Sankalp sir, for taking this master class. I will always remember this, and I will study bamboo for sure.
Yes, sir. Most definitely. I think, and many more students will get interested. Mr. Parag Rahul, whom you mentioned in the lecture, teaches in Mumbai. I think it would be interesting to meet him also and bring him on board with the students to learn more about bamboo from him. I would love to have Professor Anand Achari, sir, who is the principal of our college, and request him to deliver the thank you note.
Wonderful, sir. Wonderful. Both excellent speakers we had. Girish Doshi, sir, and Professor Sankalpa. Both have given us this master class. It's not only one. It's good to have this kind of knowledge sharing sessions and debate and discussions moving on. And from Girish Doshi sir, from his humble nature and how he has learned from his masters, Vishnu Doshi sir and V.V. Doshi, and he's learning from reading books and getting inspiration from Corbusier, and learning that art of storytelling which he is carry forwarding it. It's excellent to know, and it's also from Professor Sankalp, the learning of skill set on the level at which he has taken time to work with bamboo last few years. I assume it's more than 10 years he's working or more with bamboo, and he's coming up with this upcoming publication also very soon. That is what I have come to know. And probably this is not an end to our session, and I would look forward to more level of interaction once this lockdown scenario opens up, and probably we would like to have you in campus and share and do some kind of hands-on workshop with materials and explore these techniques. There are unlimited possibilities of collaborations and working. It's not just having one lecture through webinars or something, but I look forward for more level of collaborations where we can help the new generations which are having this thirst of knowledge and learning, and help them to grow and develop their own way of working. So thank you both the speakers for today webinar, the day 1 of our webinar 4.0. On behalf of the entire management of Vivekanand Education Society, the entire faculty of VESCO of College of Architecture, and the entire students and all the participants, I thank every one of you. I thank both the speakers for coming and sharing your knowledge and experience with our students. And I thank you. I thank both of you from the core of our heart. And we look forward for more level of interactions and discussions. And I thank the entire webinar team for a wonderful coordination of this session. Thank you, sir. Thank you.
Thank you, sir. Thank you.